If you could check the progress of your neighborhood, that'd be great. Connor, I'm gonna have you move up here for today, please. When you get a chance. You want to come up to two? You want to? A nice graph with the axes. Yeah. Max. Which one?
I'll do first one.
Okay, cotangent. Could you please? Thank you.
Yeah. Oh no. Wait, hold on.
Oh.
Wait.
Oh shoot! I'm sorry.
What did I mess up?
I don't know why that happened.
Whatever, that's whatever. Oh, this. Not the cooking stuff. It's like the negative.
No, it's like you know how can is like this, or can is like this.
It's like the other way.
It's just the other way.
Wait, I'm.
So the point is good. The 5/4, comma 1 is good.
5/2 is 0. Oh wait.
Ah,
Oh no. I is in.
People are counting same.
that's true, Simran. Lovely.
No.
Oh
No.
my god.
Yeah.
Maybe
No, that's not what I mean.
Oh, yeah, like this, but wherever it is now. Oh. Wait, hold on. No, wait, sorry, this is a little tricky.
It is a little tricky. A little tricky. Thank you.
I believe.
Maybe we could all build this one together. This is tough. This is tough.
I don't know, this one is a little tricky.
Yeah. Yeah.
I don't know. I don't know.
It's a it's a good effort. Good effort. Okay. Are we okay with the cosecant? Can you visualize the sine wave kind of swimming through the middle of it? And it actually touches like at the bottom and the top of each one of these branches. Yes, Haley. Generally, just from 0 to 2 pi is enough, but more is not a problem. And if a question asks you to graph 2 periods, then this is what I'd want. But this is really nice that we have more included. Now for cotangent, we're gonna forget that this happened. It's okay. There is some good stuff on here. For cotangent, I'm gonna go to the wellspring of everything that is trig related, otherwise known as the unit circle. L, you okay over there? Okay. So if I'm doing y equals cotangent of x, I need to kind of look at some of our benchmarks. We have 1, 0, we have 0, 1, and we know that cotangent at 0 would be equal to
Undefined.
undefined. So that's why, as what Max had, it's undefined here. Whereas the next place that it's undefined. What is it? Pi, are we good with that? So I'm gonna put that first, and I think that's where the trouble started. I'm gonna put that pi over here. So we kind of have just a place a safe place for our cotangent. We know that up at that pi over 2 on the unit circle, cotangent of pi over 2 is 0. We also know a couple other main points, don't we know? Don't we know 2 more? Pi over 4 is 1. So we have this point, and we know that 3 pi over 4 is -1. And I think Max from here, you're like, oh, of course. Do you see where we go from here? Well, from this 0, we're going to approach this asymptote over here. And on the other one, we're going to approach the asymptote going through this point. It goes right there. -1. Yeah.
Wait, when I was. Oh. Wait,
So you had stopped right here,
Yeah.
and then kind of
And then yeah.
I had a hard time recovering from that, and that's understandable. Yeah, once you start on the wrong track, it's hard to switch tracks. I think if I would have given you a hint early on, you would have been fine. And this is a full period, but we could do more, can't we? I'm gonna do 1 to the left, just like Nia did. So that means I'm gonna go all the way to -pi. And something like this. Yeah. Let's review a little bit more. Thank you for your help. For trying. Let's talk about where the inverse trig functions live. How many inverse trig functions are there? Are there only 3? There are 6. We've only talked about 3 of them. I think you know where all 3 live, don't you? Like for sine inverse x, can you show me where sine inverse x lives? Quadrants 1 and 4, which could also be considered the right side of the unit circle. Whoa. Tricky pen. Yeah, so this is quadrants 1 and 4, and cosine of x, cosine inverse of x, I should say, lives in quadrant 1 and 2, which could be considered the top of the unit circle, right? Are you visualizing the diagrams I flashed last week? And then for tangent inverse, it is 1 and 4. And this came about from when do you remember restricting the domains of sine, cosine, and tangent so that they are 1 to 1? Okay. Let's look at cosecant inverse. Okay, we have a really nice graph of cosecant right here. Would it make sense that it's the same as sine? Is it still 1 to 1 if we restrict from -pi over 2 to pi over 2?
Wait.
Yeah.
Yeah.
So like if we are right here, is it 1 to 1, right? Is it 1 to 1?
Yeah.
It's 1 to 1. So that we don't have to mess with that. It's a little bit strange because in that 1 to 1 there's a what's it called? The vertical asymptote is there, but we can't like move that. You can't say, I don't want that asymptote here, so let's do this. Right? That doesn't make sense. And if you just isolate this, that is 1 to 1, but we don't get all the y values. We want to be able to keep all the y values. So I think it shouldn't come to any, it shouldn't be a surprise that this is also 1, and I should do this in black, that this is also 1 and 4. Right, for cosecant inverse, the quadrants that it lives in is quadrants 1 and 4, just like sine. For a secant inverse, what do you think? It's 1 and 2. For cotangent inverse, well, let's take a look at our cotangent sine graph. 1 and 4 would work, wouldn't it? It'd work if we're right here. But it's a little bit weird. Yeah, it's a little bit weird with that vertical asymptote in here. So instead, mathematicians have decided that instead of using tangents quadrants, we're going to shift to quadrants 1 and 2. It's going to be here from 0 to pi. So there's a little bit of a difference here, and I'm going to put this one in red. I'm going to say be careful.
Wait,
It's 1 and 2.
I miswrote my four. Yeah, 1 and 2. From 0 to pi. Cotangent inverse lives in only the first two quadrants. So please keep that in mind. So if you're answering a cotangent inverse problem, your answer needs to be from 0 to pi. Whereas if you're answering a tangent inverse problem, the answer needs to be from negative pi over 2 to pi over 2. Yes?
Yeah.
Okay. So let's move on to just a little bit of exercise of inverse functions. What does a function and its inverse normally do? Cancel out? Does that make sense? A function, they kind of cancel. They undo each other. Multiplication is inverse of division. They undo each other. So let's talk about what happens when we have, and this is the beginning of your notes, or I guess the extension of your notes. We've talked about this today. So if we have sine of, well, let's do sine of sine inverse. Does this equal x?
Oh, there.
no, it does not.
Depends if it's in 11.
It depends. Do you remember what the situation is called when you have a function in another function? Composite function. Do you remember the diagram that I made for composite functions?
Yes, it was like the pineapple and the pizza.
Oh, I probably use that as an application of it.
But like,
It is more of a function machine. Function machine.
no, but that was the graphic of like if you put pineapple in a pizza, then it makes sense. We don't put pizza in a pineapple.
Oh, that's interesting.
By the way.
I didn't do that, but I like that. I like that. So here we have two different functions, and this is just kind of my thought process for this. So, what could go into, well, first of all, which function comes first?
Probably we will.
Well, think about where x goes. First thing that happens with x goes into the inverse. So, okay, so that's the first function. And what numbers can go in here? Are you with us? We could go from, thank you, Shiv. I could always count on you.
Yeah.
-1 to 1. It's the inverse, right? It's the outputs of the basic sign that come, right, that they switch.
That's the,
Perhaps you remember from the graph, right? Here's the graph of sine inverse. We're putting numbers into the inverse, so we could put the range from sine into the inverse. But remember, here's sine inverse. Those are the only numbers I could like.
I thought we doing this sine inverse was negative. But
Absolutely. Right, here's the graph of sine inverse. Domain is -1 to 1, range is -5 to 2. Remember that -1 comes from the fact that the range of sine is -1 to 1. So domain of sine inverse is -1 to 1.
those would be flip time.
Yeah. The range of this one, negative pi over 2 to pi over 2. That's the two quadrants that we're talking about. That's quadrants 1 and 4. So after that number comes out of here, it's going to be put into sine. So this is a sine function. And what comes out? Of a sine function, what comes out? -1, 1, doesn't it? Doesn't it? Out of a sine function, numbers that come out are from -1 to 1. So this is true if x is an element of Really, any real number?
No. This is in the range and.
-1 to 1. Yes. In other words, these will cancel, sine and sine inverse will cancel in this situation as long as the x value is between -1 and 1. Yes, Oliver?
You did the domain of sine inverse of x,
Mhm.
and then you do the domain of sine of x.
No, then then I put the output of sine
And
inverse.
it's a range. And so that's also the domain.
And then this becomes the inputs into this one.
Yeah.
It's not the full domain of sine of x, it's a limited domain, right?
Well, yeah, that's the restricted one, but yeah.
Yes, exactly.
But, and so that, this is, it's not trying to find a solution, it's trying to find the domain in which they equal that.
I'm showing a relationship that this will cancel if the input is between -1 and 1. And we're gonna do a few of these. I don't want you to memorize anything. I want you to understand the workflow. So give it just a minute. Chloe, do you have a question before I continue? Okay. The next one we're gonna do is sine inverse of sine of x. Does that equal x? Well, let's work through it. In this case, the flow is different. Okay, so the x first goes into sine. Now, what numbers could go into sine of x? Any number? Is this true? Into sine of x?
Well,
Can you do any number?
yeah.
You can, yeah. Any number could go into this, can it?
Yeah.
Sine of 1,000,000,000? It's fine. It's on your graph. It's fine, somewhere. I'm just talking about function in general. And hold on. They'll all come together. What comes out of this? -1 to 1. And in this case, that -1 to 1 goes into sine inverse. And what comes out? -pi/2 to pi/2. Notice this and this don't match, do they? So the only time that this will be true is if we don't plug in just any number, but we plug in numbers between. That should be if, yeah. If x is between -pi/2 and pi/2. I'm just trying to tell you when sine and sine inverse cancel. Or inverse sine and sine, when do they cancel? And it's more of a workflow issue. It's not like, again, don't memorize this, and we're gonna work through some problems to help you with it. We're gonna do 4 more of these problems. You know which ones we're gonna do? We're gonna do the 2 of them for cosine. So cosine of cosine inverse. When does that equal x? When does that equal x? It means equals x. For instance, if you have like the square root of x squared is x. As square roots of squares are inverses. It's kind of x.
Oh, yeah.
Wait. Like negatives for the domain.
We're gonna start discussing.
Building it, I do. Like, want the domain. And then, and that's about it.
Oh, I get it. Wait. I'm so bad. Oh.
No, that is, yeah.
Oh my God. We are working. So you put in the. Feels good.
You get that?
Yeah.
From. Yeah.
Okay. So maybe just one more.
Yeah.
Wait, that would be the price. What's the date?
Next.
Like six.
Well,
Yeah, the price. Like that's. Would you say? So you put it. Yeah, it's fine. Oh, wait, you know, I see, I learned that. Somewhere in Europe.
Wait, did you get that?
Yeah, I think so.
Just about one more minute.
If negative. Wait for. Okay, wait. Cosine's domain. Yeah. I got one. Oh, wait. Wait, is cosine's domain like what? All of them? You already said it.
So like those.
Isn't that cosine?
Cosine is versus range of 0 to 5.
And then cosine domain.
Like when restricted, the domain 0 to 5. And then when you.
10 seconds.
Wait,
Okay,
I really would love to help you, Sarah, but if the air mass thing.
so your attention, please. I don't want to overcomplicate this, but what I do want you to just keep in mind is that if an inverse trig function is present, proceed with caution. Yes, proceed with caution. So did you get an answer for that third one? If x is, what is it? From -1 to 1? That's exactly what it is. And for the fourth one, it's from 0 to pi. Now, again, this shouldn't be a surprise. When we look at this problem, I hope it makes sense that overall it's a sine inverse problem. When you see sine inverse, I need you to think about an angle. Yes, anytime you're talking about inverse trig, it's talking about an angle. So it shouldn't be a surprise that the answer is going to be an angle between -pi/2 and pi/2. Same thing with this one, cosine inverse, that is ultimately a cosine inverse problem. So the answer is going to be an angle in the quadrants that we were talking about. Tangent's interesting. If we do tan inverse of x, what could go into that? All real numbers could go into tan inverse of x? Is that true?
Can you show me the graph of tan inverse x? Do you have it handy? Yeah. It is all real number. Yeah. And the output? The output of tan inverse x?
negative pi over two to pi over two, of course, and this is non-inclusive, and then when that goes into tangent, then the answer is, yeah, all real numbers. So in this case, it could be anything. So whatever you plug in will cancel. Yes. Yes.
Oh, yeah, it's vertical.
It has horizontal asymptotes. Yeah. Tangent has the asymptotes. Yeah. Yeah, so tangent inverse looks something like this, right? Tan inverse. So you could plug in anything. That's fine. All real numbers go into. So I'm reversing them. Tan x. Could anything go into this? Into tangent x?
It's negative pi.
Almost anything could go into it, can it? Except all but asymptotes. Should I just say that as a idea? All but asymptotes can go in there. And then what comes out of there?
Negative.
Negative to infinity. So all real numbers come out of tangent of x. Yes, goes up and down forever. And then I think we could plug all those numbers into tan inverse of x, can't we? And what comes out of tan inverse of x?
All.
Negative pi over two to pi over two. So again, this is a tan inverse problem, so we just have to be careful for all of this.
Okay. Those are the asymptotes.
The horizontal asymptotes now. Yeah, so we couldn't plug in like pi over two. That's so powerful, it can't come out. Let me make it clear that this is non-inclusive of asymptotes. Good catch. Yes, Emma. Yeah,
So maybe, I mean, when you, what I was gonna add is gonna be the.
exactly. Yes, good. So for instance, if you see something like this, pi over 7, do these cancel?
Yeah.
This is inverse sine and sine cancel.
Yeah.
Yeah, because pi over 7, there's definitely no issue. It's in the first quadrant. It's a really friendly angle. How about if we have sine inverse of sine of 4 pi over 7? Do these cancel?
No.
Yeah, it doesn't. The output needs to be between negative pi over 2 and pi over 2. So we need to analyze a little bit. Could you figure out what this is equal to? Okay. Now 4 pi over 7, that's not a standard place, but we know where it is, don't we? It's in the second quadrant. It's like right there, isn't it?
Yeah.
We divide that top half into 7 parts. It's going to be
It's
just less. A little bit more. A little bit more than half.
not part of inverse sine.
And it's not part of inverse sine. So what we need to do is we need to find a place that has the same sign value. And either the first or the final.
The top, the five.
Wait.
Do you see a value in here that has the same
Yeah.
sign value as 4 pi over 7? Check your neighbor.
I'll find that.
No.
Oh, what's nine?
What's the number on top? Does that make sense? If those are equal? It's saying what value?
Oh.
I know.
Oh, how far is it from here to pi? Yeah, right. Isn't it 3 pi over 7 to get all the way over here? Isn't that what this is? 3 pi over 7? Yeah.
Wait.
Or if you think halfway being 3.5 pi over 7, isn't it? So 4 pi is on to instead. 3 pi over 7. Oh, yeah.
Wait,
But yeah,
why is it positive?
if I'm talking about just size of an angle, I'm just talking about from here to here. So I'm thinking big minus a small 4 pi over 7. It's going to give me that 3 pi over 7.
Or why can't you just talk on time?
There are different ways to do it. So you can.
Different, like the answer. Doesn't matter.
Depends what you're looking for. I'm just looking for the measure of this angle, so I do big minus small. So since that's super, yeah. Because I want to put in the first quadrant. I want that angle to go in the first quadrant. Right, I don't want this point down here. I want one with the same y value. Okay, so it's over here. Yes, exactly. We're looking for an angle in quadrant 1 and 4. So that now we can take this and cancel. 3 pi over 7 is the answer. Yeah.
Yeah.
That's a doozy. Whoa. Thank you.
You know that one?
I don't know. Any questions? Okay, I even say one, just go over one more time. Here, this sign inverse and sign canceled, and there was no problem because pi over 7 is in the place where sign inverse is. We didn't have to worry about it. Here, I have to be careful because 4 pi over 7 was not there, so I had to analyze which other angle has the same sign, SINE, as sine 4 pi over 7. I just moved it from here to here. I hope that visually that makes sense. And then this angle is 3 pi over 7. Oh, I put over 4 over 7. Thank you. That's called autopilot. Okay, we do have to move on. What am I going to talk about next here? Oh, you're gonna do some problems. Is that right? Yeah, I think you're ready to do some problems. From the packet. Let's go to page 18. Yeah. Some of these are gonna be a stretch more than others. Take some time to think about them.
Tan inverse. Well, that's my mind. Okay.
Scary. Do you want to talk through the first one together? We're on page 18. Page 18. In this class, in order to do any problem, you need to have meaning. What does this mean? Find an angle whose cosecant is -2. Are we good with that? Anytime you see inverse, it's talking about angle. So I'm gonna actually think about this as an angle. That whole thing is angle. Angle whose cosecant is -2. Yes, just right. So this is saying specifically, not cosine. This is saying the cosecant whose angle is -2. Does that make sense how I went from there to that?
Oh, yes, because the input's enough.
Empathic. I want you to think about what your neighbor had through this problem.
So now it'll be one, so time, one half, time, one half. Yeah.
I'm thinking,
Yeah.
Negative 5 was it?
Yeah.
I was
Why is it? Yeah. Oh, no. Yeah, cotangent. Zero.
That's either negative.
Am I allowed to write it like equal to all the same?
One and two.
So it'll. So.
Are we ready to finish this one?
Yeah, we did it.
Where do we go from here?
1/sin x.
Either 1/sin, or we could say sine of theta is equal to -1/2. Do you remember those exercises from the beginning of, I think, the last units? Right, like if you had sine theta equals 4/5, then you just said that cosecant theta equals 5/4. Remember when we did the list of 6? That still works. Okay, so now the question is, in this problem, where is sine theta of what equals -1/2? You know? -5/6. Are there other answers? There are other answers, but remember, cosecant inverse lives in the same place as sine inverse. So we're looking only for angles in quadrants 1 and 4, which is why this is the only answer, -5/6. That's it. Yes. Yeah, you have to go this way to get there. Good question.
Oh. We did something wrong. Always sign Jada. Let's just say we did that.
I've got him. We just because
Oh my gosh.
because potential is basically a two, that's when where is you know.
Oh, bro.
Just about 2 more minutes to do what you can do. So
Forever. It's Boston.
yeah, so I always know Canton. Potential is the big one. Oh yeah. We will.
Oh, no, I would be greater than one. Okay, so I was thinking, sign the statement. Oh.
1 more minute. It's not, no, it's not, that's not how. That's, you can always have. Oh, for anything like. And what it usually that you do, that's, no, but that's for outfits. This is. Still do it. They're equal to each other. Yeah, I know. You can't find what you can. That's fine. No. So we're gonna have to start. 1/9. It's like, okay. It's a very fine line to see. So if you have, you can't take it, right?
Your 10 seconds, finish up your discussion. Okay.
I know you don't.
Wrap it up. Okay. No more talking, please.
No more time.
I just want to go over a couple of these. Now, my main goal is for you to be able to work through and figure things out, and I saw a lot of really good things here. It's interesting. We start with this one. This is too challenging of a problem to start with, I think. But what is this even asking? The cotangent of which angle is equal to 0? Yes. Is that in our warm up?
I feel like it was.
Yeah.
Is that in the warm up? Is the answer to this in our warm up? Do you see it?
Yeah.
The answer is pi over 2, isn't it? Well, here's a pi, so this is pi over 2. We could survive that. It's pi over 2. Okay, so that's what that answer is. It is pi over 2. And that's right in the range that we were from 0 to pi. So, did you already get that? Pi over 2. Nice, you got it. Good job if you didn't. Hopefully it makes sense now. I'm not going to go with this one. Well, this one, hopefully you just figure out where secant is equal, like is on the unit circle. Do that. I know you can. I want to talk about this one. Maybe do this in 2 different ways. I'm just going to do it in one move. I don't like that 1 over. Instead of 1 over, I'm going to write this as cosecant of 7 pi over 6. Yes. Maybe you didn't do it that way. Maybe you actually found that. Well, let's see. Do these cancel?
Yeah. We know that.
Guys, be careful. Cosecant lives in quadrants 1 and 4, specifically from negative pi over 2 to pi over 2. Actually, this one yeah, so what I have to do is I have to find in the unit circle a place that has the same sign value as this 7 pi over 6. So which one is it? Are we good with that negative pi over 6 here? I can write this as cosecant inverse of cosecant of negative pi over 6. And once we have this, they cancel, leaving us with negative pi over 6. Now maybe you actually found the value there, and that's fine. I mean, you have, I don't know, what is this? Negative 1/2, is that right? I mean, it became cosecant inverse of negative 2. Is that absolutely better? That's fine. It's fine to do it that way. I just want to illustrate the process of it. This one. Do these just cancel? Yeah. Yeah, this is just negative. Okay, so we have problems. You're gonna see some of those in your assignments tonight. Please. Always is a little scary. If it is, yeah. For these, it will always equal x with those restrictions on x. I do have to move us a little bit forcefully to the next unit and the next portion of today. And it's still tough. Sheesh. You did not do well this last quiz. That's when they either quiz at the beginning, right?
Wait, what?
It's 4 points.
Oh, I don't know. It's 8.
The other part.
Honor should take me yesterday.
Still can't.
So it's going to be part. Gonna be the yeah, you can start.
I do my homework.
Very good.
The original one? Did anybody?
Yeah. Yes, they were. Right. Those are perfect. And so I mean, you don't have to say it fast off. Yeah, that's right. So ultimately, each group is going to turn in 1 sheet.